So this is lesson 8.3 in the textbook. Looking at quotient powers, dividing powers, similar bases with different bases, looking at the different properties. So jumping right in. Number 1, 2 to the 7th divided by 2 to the 4th. When we look at that, those are similar bases. So the property says that we can just subtract our exponents. Now, for this first one, I want to just remind us why we can do this. So 2 to the 7th is 2 times itself, 7 times. And you're dividing it by 2 to the 4th, so 4 times. And we've talked about how these are dividing themselves by themselves, and that just creates 1, and so we're just left with this. Now, we're going to write this as a single power, so we're not actually going to do 2 times 2 times 2 and then get the singular answer. We're going to leave this as 2 to the 3rd. So this kind of shows why it works. When we look at this, we really want to see the property 7 minus 4 gets you the 3. This is why we can jump straight to the property. We want to understand why the property works. But once we do understand it, we just want to use the property and make this faster. So problem number 2, we have 8 to the 5th divided by 8 to the m. So if you look at our two exponents, one's a number, one's a variable, and so we can't actually combine those, but we can write them as an expression. Because these are similar bases, we would be subtracting this. And so this is going to be 8 to the power of this minus this. And since we can't do anything with this, we're just going to write that expression out. It's going to be 8 to the 5 minus m. So problem number 3, we have 3 to the m over 3 to the n. And so same idea, it's a similar base, so this is just going to equal 3 to something, which is going to be the difference between these two, so m minus n. All right, we're doing 1 through 9 here, so just keep going. Number 4, let's see if we can get that in focus. All right, we have x to the 12th over x to the 2nd. Very straightforward, same base, so it's just going to be x to the difference here. So that is x to the 10th. Number 5, a to the 20 over a to the 20. So what we're going to do is we're going to keep the base since it's similar, subtract, it's a to the 0. Okay, anything to the 0 power is 1, and anything divided by itself is 1. So it is possible to look at this and go straight to here. But we also want to recognize that when we do subtract those to the 0 power, a to the 0 is 1. This is also a good explanation of why that is true, that property. Anything to the 0 is 1. We know anything divided by itself is 1. So that's another reason that this equals 1. All right, number 6. All right, we've got scientific notation. So all different questions on how do we write our final answer? How simplified does it need to be? And those are all valid, and we're not too worried about that. This section's about the exponents, so that's what we're really worried about. So what I'm going to do is I'm going to go ahead and just leave these leading numbers alone and just worry about this. I have the same base here of 10, and so I'm going to be subtracting these numbers, so 21 minus 19. So I'm left with 10 to the 2nd. 10 to the 2nd is 100. 6.5 times 100. All right, it doesn't go on the bottom because anything we're left over with is going to be positive. It's going to be up here in the numerator. And so we're going to leave that 3.1 down here on the bottom for now. And if we will go ahead and we just multiply by 100, that moves that decimal 2 spots. So it is 650 over 3.1. In some places, they'd like you to move that decimal on the denominator so that we don't have it. Now, this is the book answer, so this is perfectly fine. But this would be equivalent if we moved it over and got rid of the decimal completely. So we move the decimal 1 on the top, move the decimal 1 on the bottom. Okay, and they're going to be equivalent, and then you don't have that decimal. That's fine. If you divided this and then you got some other number, that's fine too. But if it's going to give you some nasty decimal you got around, we talked about that, we'd rather just leave it like this. All right, not too worried about the scientific notation there. Again, really just focused on the exponent properties here. number 7. Okay, we got some leading coefficients here, and we've got different bases. So our coefficients, we're just going to go ahead and do the math. It's dividing, so don't subtract. This is 12 divided by 2. Okay, so I do get 6 there. This a down here really has a 1, so 2 minus 1 is just going to be 1. So it's a to the first, which I'm just going to write as a. And then 12 minus the 7 is to the 5th power. Can't put those together, different variables, leave them separate. Okay, question number 8. Now in this one, if you do 2 divided by 8, you're going to get 0.25. And if you wanted to leave 0.25 out in front, that's fine. But we're going to leave this simplified. Okay, so it's really going to be 1/4. So it's a 1 on top and it's a 4 on the bottom if you simplify this. But if you just did 0.25 because you divided 2 by 8, nothing wrong with that. Nothing said that we had to leave this as a fraction. Okay, it says simplify the fraction, but simplifying could be writing it as a decimal. That's fine. So really focused on the exponents again, not getting caught up in the semantics of simplifying. So just looking here, similar base, we're going to subtract. Okay, so that's going to be a to the 2nd power. And this is b to the 1st. So when I subtract here, 9 minus 1 is 8. So this is the answer you'll see in the book. We won't have the 1 in front because we know we don't need the 1 as a coefficient. So it'll just be a squared over this. But you could leave it with the 1 there. It's nothing wrong with it. There's the book answer. But again, if you divided 2 by 8 and got 0.25 and left your answer as 0.25 a to the 2nd, b to the 8th, that's equivalent. Nothing wrong with that. Okay, and number 9. So look at this one. I'm going to go ahead and divide. That's going to divide nicely. So my leading coefficient here is 4. A to the 10th divided by a to the 4th. We're going to go ahead and subtract that. So that's a to the 6th. And then b to the 5th, b to the 5th, they basically cancel each other out and become just a whole number 1. B to the 0 goes away, so we don't need that in the answer. And so we're good right there, 4a to the 6th power. Okay, after number 9, we jump to 16. We'll stay right here. So the bases are a little fancier here. It's not just a single variable, it's this entire thing. But because it's all in parentheses being raised to the power, this is the base, all of it. All of it's being raised to the 5th. And if we look at the numerator and denominator, they both have the same base of 7m. And so my final answer is going to just be that base raised to. And so since I need the whole base raised, I do need it in parentheses. If you don't keep the parentheses there, the exponent is just going to the variable. And 5 minus 3 is 2. So that's my final answer. Similarly here on 17, they've given you a little bit of a more extravagant base, but it still holds to the same properties. So these are exactly the same. They're being divided. So we're going to keep them and just worry about the exponents. So the base stays the same. 7 minus 6 is 1. So if you want to put the 1 there, you can. Of course, in the book, they're not going to have an exponent of 1. So their final answer isn't even going to have parentheses. It's just going to look like this, but all equivalent. Okay. 18 starts to get a little tricky. You got to think a little bit. So the base is the same, right? It's x raised to something. So it's going to be x raised to something. And I'm going to take this one extra step. I'm going to actually write out the whole subtraction statement so you can see why the answer is what it is. You may have done this one already and couldn't figure out where the answer came from. So remember, you are subtracting, and if you can count this as a negative in your head, you can do this without rewriting it. It's 5 minus negative 3. This is negative 10 minus 3. So if you understand that, looking at it that way, you can get straight to your final answer. What I'm going to do is I'm going to write this out. It's this whole top one, so I'm going to put in parentheses 5a minus 10 minus the whole bottom quantity, 3 minus 3a. So if we just ignore the base for a second, this is the problem that we have to solve. And we worked on these earlier in the year. When we are subtracting an entire quantity, you actually do need to distribute that like it's negative. So this becomes a minus 3 or negative 3, and this is a negative and a negative, which becomes a plus 3a. So it's 5a minus 10 minus 3 plus 3a. So final answer, again, the base is still x. But when we combine this, it's 5 minus negative 3, which is the same as 5 plus 3. So we're going to have an 8a. And it's negative 10 minus 3, which again, if I go back to here, negative 10, subtracting the bottom minus this 3. And so that's a negative 13. So I write that as minus 13. It's a little bit tricky there. And then number 19. All right, so before we move forward on this, we've done some properties where we could split this into two separate fractions, both over the denominator. Nothing wrong with that, that would work. Okay, but I think the best practice here would be to actually simplify the top. These are like terms. They have the same variable with the same exponent, which means you can combine your coefficients and simplify it into 1. And so 2a to the 6th plus 6a to the 6th is 8a to the 6th over 2a to the 5th. And now it's a very simple problem to do. The 8 divided by the 2 gives you the 4, and 8 to the 6th divided by 8 to the 5th. It's just going to leave you that same similar base. Subtract your exponents. So 6 minus 5 is 1, and so that's 4a. All right, and after number 19, we have 23 to 26. So down here at the bottom of the page, we're in the review section. So we're going back to some products here, not quotients. We're not dividing anymore, we're multiplying. So we're just going to multiply here, which means we are adding our exponents. Quick review from last section. So the coefficients still get multiplied. It's 3 times there was a 1 here, so it's still 3. And when you multiply x to the first times x to the second, you're going to go ahead and you're going to add the exponents. And so it's 3x to the third. Remember that this one on 24 actually is n to the first. They're all the same base, so your final answer is just going to be that base. Since we're multiplying everything together, we're adding our exponents. So 1 plus 2 plus 3 leaves you n to the 6th power. All right, make things a little more complicated here. We do want to follow our order of operations here. Multiplication would be first. So let's go ahead and simplify that first and leave the addition here in the middle. So when I go ahead and I multiply, coefficients will go through. So that's 12. And when I multiply h to the third times h to the fourth, I add the exponents. Oops. And so 4 plus 3 is going to be 7. And when I go ahead and multiply here, that's 12. This really has a 1, and so the h to the first times h to the 6th, you add the exponents, so that's h to the 7th. And so you'll notice I can't actually combine these. I would have to leave this as an expression of two things being added together as a sum if I didn't have like terms. But after I did this multiplication, I got h to the 7th, and after this multiplication, I got h to the 7th. So regardless of the fact that the coefficients are the same, that doesn't matter. In terms of can I simplify and combine like terms, here h to the 7th does combine with h to the 7th. So I can go ahead and combine the coefficients to get 24h to the 7th. So kind of going back and looking at a bunch of different properties we've studied so far. All right, and we have come to the last question, number 26. All variables. No numbers here. Okay, so just examining the property here, it's the same base being multiplied. So my answer is going to be the base, and the exponent is going to be all of these added together, just like we added here to get 7. So we're adding all of these. Now, since they're variables, we can't actually combine them. So we have to write it as an expression. So I'd be taking whatever x is, adding whatever y is, and adding whatever z is. And that would be the value of my exponent. So final answer is a to the x plus y plus z.